Hey, Food Science, welcome back. So in the previous video, we learned a little bit more about chemical formulas and how those are comprised. So we know that H2O, for example, has two atoms of hydrogen and one atom of oxygen, right? So we learned about how chemical formulas are comprised. This video, we're going to talk a little bit more about how those formulas form chemical bonds and what those chemical bonds look like. So a chemical bond is a force that holds two atoms together. These bonds are formed by electrons, and we know that electrons are located on the outside of the nucleus, so they're not in the nucleus, they're on the outside and they're negatively charged. And just for review, inside of our nucleus, we have our protons and our neutrons, right? Protons are positive, neutrons are neutral. Okay. But our electrons form the bond, they're on the outside, that is the outer shell, okay? They're on the outside and they're negatively charged. The space around the nucleus with one or more orbitals is the shell, and atoms can have up to 7 shells. And remember, our periodic table has 7 different periods, right? So the number of shells determines its position, or the element's position or row on the periodic table. So period 1 elements, so hydrogen and helium, are going to only have 1 shell. But period 2 and period 3, period 2 is going to have 2 shells, and period 3 is going to have 3 shells, so on and so forth. Okay. So besides period number 1, which is hydrogen and helium, all other periods are going to have up to 8 electrons in the outermost shell. Okay, we're going to talk about that here in a little bit. But over on the right-hand side, you'll see me reference this here in a couple of slides. But this is known as a Lewis dot structure. And this is kind of a shorthand way or a diagram for us to recall how many electrons are in the outermost shell. So we know that hydrogen has 1, carbon has 4. If there's 1, that tells us that it is in the first group, right? And if there's 4, it tells us in the fourth group, and so on and so forth. The ones where there are multiple different elements combined into a molecule, like water, for example, this shows us how many electrons are formed when these different bonds occur. These lines over here indicate that there is a chemical bond. Okay, so we know that two hydrogen atoms bond to an oxygen atom to create a water molecule. Atoms are most stable or happy when the outer shell is full of electrons. Remember, as I said in the previous slide, as we move from left to right on the periodic table, we are going to gain more electrons. So, for example, hydrogen is only going to have 1 electron on the outside, whereas helium is going to have 2 because it's farther over. Okay? Atoms that are not stable will tend to share or transfer their electrons from one atom to another to make it happy. Okay? So again, this is our Lewis structure diagram over on the right-hand side. 1 valence electron is going to look like this, but if we have 8 and it's full, it's going to look like this. So each dot represents a different electron that's being added. So now we're going to talk about ionic versus covalent bonds, and they're a little bit different in that ionic bonds occur when electrons are transferred from one atom to another. An example of this is table salt. So if you look on your periodic table, you will notice that Na, or sodium, is located in the first group of the periodic table. That means it's on the far left, just like underneath hydrogen. Okay? Now, if you look at chlorine, you will notice that chlorine is located in the 7th group. So that means there's going to be 7 electrons in the outermost shell. The sodium transfers its 1 lone electron to the chlorine to make it full, to make it a full 8. Okay, this creates a negative charge in the chlorine because it is receiving an extra electron, and a positive charge in the sodium because it is sharing that. This is known as an ion. So an ion is an atom with a positive or negative electrical charge. So a cation is positive, and anion is negative. So in this case, with the sodium and chlorine, the sodium would be considered our cation because it is positive, and our chlorine would be considered negative, or an anion, because it has a negative charge. It is receiving. It's kind of opposite. Okay, so when you share something, or when you're giving it away, when you're giving away your electron, you are positive, you are a cation, and when you are receiving it, you are the donor, or you are the recipient, you are a negative charge. So in this case, the chlorine is negative charge. Donors are positive, recipients are negative. Identical charges tend to repel each other, but opposite charges attract. They say that a lot about people in life too. Opposites attract. Similar here with bonds. That's where that saying came from. Substances with ionic bonds tend to have a crystalline structure, kind of like salt. Salt is a crystalline structure. That's the example we just looked at with NaCl. Dissolve in water and are considered to be metals or nonmetals, not metalloid generally. So that's a little bit about ionic bonds. Ionic, again, means transfer. Covalent, on the other hand, is when electrons are shared to form one or more pairs of electrons. So, for example, oxygen shares 2 electrons in its outer shell with 2 hydrogen atoms to form water. A Lewis structure, as we talked about on previous slides, is a shorthand option of diagramming the valence electrons, and valence electrons are the amount of electrons on the outermost shell of our element. A double bond forms when 2 atoms share 2 pairs of electrons, and we're going to look at an example of this here in a little bit. Water is an example of a polar covalent bond. Okay, so we see over here that we have our 1 hydrogen electron, 1 hydrogen electron, and those are being shared with our oxygen to form a full valence electron shell. So we have 2, 3, 4, 5, 6, 7, 8. So our whole oxygen outer shell is happy as a result. If you take anything away from this short presentation, I want you to know this. Covalent bonds means that electrons are shared. Ionic bonds mean that electrons are transferred. Hopefully this diagram kind of helps make sense of that. If you have any questions on covalent versus ionic bonds, please feel free to reach out. This is kind of a tougher concept to grasp, but if you have any questions, rewind, rewatch, ask for help. We'll get through this. All right, have a great rest of your day. Thanks for watching.